So here we are, 5.7b, and has to do with deer population, example 4. And we have the equation that they give us at the beginning, and they give us some numbers here because it has to do specifically with this deer population. So they give us 1,000, and tells us that in the beginning, well, in fact, that's what we're supposed to find here. So let me concentrate on writing this out first. 0.2, and that's to the t power. All right, so what they're asking for first is what is the number of the deer on the island now when t equals 0? So what we're going to do is we're going to put a 0 on this exponent of 0.2. Anytime you put a 0 as an exponent, the number that the exponent is on, or the letter or whatever, automatically becomes 1. So now we have 1,000 times 0.06 to the first power, or 1,000 times 0.06, which means for A, we have 60 deer on the island to begin with. Okay? So, B is saying, all right, so if we had 60 deer on the island on day 1, how many deer are predicted to be on the island 1 decade from now? Okay, so notice the instructions say predicts the size of a deer herd on a small island t decades from now. So we're not looking at years. T represents decades. So when t equals 1, so what we're going to do is we're going to put a 1 there. So 1 there does not change this. So it becomes 0.06 to the 0.2 power multiplied by 1,000 gives us an answer of 570 deer. Okay, so in 10 years, we will have 570 deer. We started with 60, have 570 in 10 years. And this is how wildlife biologists kind of get an idea of what's going on. Okay, C, graph the function. Put the information in there and come up with a graph of this function. All right, D, what is the maximum number of deer predicted by this model? Okay, the maximum number of deer is predicted to be 1,000. I mean, that's what we have right here in the formula. That first number there is the maximum number that we're looking at. It's the C. And if you look back at the other formulas, they all have a C there, and that C represents the maximum number you're going to have. Okay, so E, in how many years will there be 840 deer on the island? Okay, so this is the part that you're actually doing some hardcore algebra in order to figure out. All right, so N is our 840. So 840 equals, and this is what we're looking for. That is going to be a tough one, right? Well, we just follow stuff we already know, and it will work out. So that's what we're looking for. How many years will it take, or in how many decades will it take for us to have 840 deer? Okay, so let's just do the math as simple as we can. We're going to divide both sides by 1,000. That goes away. So we have 0.84 equals 0.06 to the 0.2 to the t power. All right, because we have exponents, our variable is an exponent, we're going to use logs. You can either use log, natural log, or common logs or natural logs. I'm just going to use natural logs because it's ln instead of writing log, so that's the only reason. It's a 6. All right, now if you remember right, the exponent then can be moved in front. Then I'm going to divide both sides, and that goes away. Okay, let's move this up a little bit. So the book doesn't go over this at all. Okay, so just kind of focus on what I'm doing here, and we'll see if I can cruise along here and do it correctly. All right, so when you take this here, ln of 0.84 divided by ln of, what do we have, 0.06, we get 0.06. 0.06197225, and it goes on and on and on forever. Now we take the ln of both sides. Okay, and when we do that, again we have an exponent here that can now be, my equal sign over here, can now be put there. So now I have ln of 0.2 on the right and ln of this over here. So I'm going to divide both sides by ln of 0.2, and that takes care of all of that, and that equals t. All right, so now that I'm at this point, I have ln of this over ln of 0.2 equals t, and I find out t equals 1.728 decades, which will be approximately 17 years. Okay, bringing us to example 5. And example 5 is done pretty much exactly like what we just did that one. And again, the book doesn't show the work. I'm assuming they're just thinking you're going to, well, yeah, they're using graphical methods to determine the year in which the number of employees is predicted to be 1,000. Okay, so they show you graphical. I'm going to show you the algebra to it because this is college algebra, and I do think it's good for you to kind of see that the math actually does work in doing this. And that's to the t power. So we've got these guys that started this company, and they're wanting to know how long it's going to take this company to grow to the point where they have 1,000 employees. Okay, so there's our formula right there. And t is the number of years from the present. So that's what we're looking for, is t. N, we're going to change to 1,003. Now we're changing it to 1,003 because we not only have 3 owners, but we're going to have 1,000 employees. So that's why it's 1,003. So how many years is it going to take for us to have 1,003 employees? And there is our formula there. So given that, we're going to divide by 2,000, and that goes away. And this is going to end up being 0.5015. Fortunately, there's not as many decimals in this one. Okay. Now what we're going to do is we're going to take ln of both sides. Again, you can take logarithm, but log is a lot longer to the right than ln. So that's the only reason I'm using ln over lg. The only reason. All right, so 0.004, 0.05 to the t power. Okay, that being the case, I'm going to move this in front. Then I'm going to divide both sides by ln of 0.004, and that goes away. And I have that there. And when I divide this out, I end up with a number similar to, well, it's not really exact because I'm only going to 6 decimal places here. Okay, I still have a variable in the exponent position, so I'm going to take the ln, well, that doesn't look like an ln, does it, of both sides, and then this exponent is going to move in front, just like I did before. Okay, then I can divide by ln of 0.05. Get rid of that, and that will give me my t. And my t then is found to be approximately 3 years. So in 3 years, I will have my 1,003 employees. So I've got the owners, 3, and my 1,000 employees, all in 3 years. Okay, so that's it for 5.7. Not really too terrible. You look at the homework, you look at the formulas, and it looks a bit crazy, but you'll notice as we do these, there's really nothing too terribly difficult. It's just kind of same old, using your algebra skills, using your logarithmic skills, and you should be just fine.